This video is on the clear and preset inputs of a flip-flop. Often JK flip-flops as well as edge trigger Ds and even RS flip-flops will have two additional inputs, one labeled CLR that stands for clear and the other one labeled PST which stands for preset. So I think the best way to, actually I forgot to put this here. Okay, so that's our symbol for the JK along with the clear and preset. Now, if you see a little bubble, and actually I forgot to put the bubble on the clock input because this is negative edge, okay, like we saw before. If you see a bubble on either clear or preset, what that bubble means is active low. Okay, so this is an active low preset, this is active low clear, and active low just means that it takes a 0 on that input to make preset happen. Just like down here, because of this bubble, this indicates that in order for the clear to happen, it takes a 0. There are also active high presets and active high clears, and you would not have the bubble on the symbol for the input if it was active high. An active high just means it takes a 1 to make the clear happen or a 1 to make the preset happen. So I think the easiest way to show how preset and clear works is to take the truth table of the JK flip-flop that we had earlier and then just see how it's modified by these two inputs. So first of all, if preset and clear are not activated, well then the outputs of the flip-flop are just going to be determined by the other inputs. So since these are active low, if both of these are 1s, which means they're not active, well then the Q outputs are just going to depend on JK and clock, just like if we didn't have those inputs. Okay, but let's see what happens when we activate, say, clear. Okay, well if we activate clear, we do not want to activate preset, okay, because clear will make the Q output go to 0 no matter what the other inputs are equal to. And preset, when it's activated, it will make the Q output go to 1 no matter what the other inputs are equal to. So you would never want to activate clear and preset at the same time, because when they're activated, they make Q do opposite things. Clear makes Q go to 0 and preset makes Q go to 1. Okay, so it wouldn't make sense to activate both at the same time, because you'd have an output trying to go to each extreme. And what would end up happening is you would end up somewhere in between and you wouldn't really know what you had at the output. It would be an ambiguous type of output. So if you activate clear, you do not activate preset. And when you activate clear, the other inputs, J, K, and clock, they don't matter. Okay, what a dash stands for here in the truth table is don't care. Okay, this is the first time we've seen this. You know, don't care, or, you know, doesn't matter, however you want to say it. Okay, so you see when clear is activated, the JK clock inputs do not matter, and when we activate clear, we want preset not to be activated. And when you activate clear, it's going to make the Q output go to 0. And if the Q output is 0, since there's no ambiguous state with the JK, then not Q is 1. Okay, so that's what clear does. Clear is a dominant input that when it's activated, it takes over from the other inputs and it makes Q equal to 0 no matter what. Okay, so that's how the clear being activated modifies the JK truth table. Now if we're going to preset, okay, since it's active low, to preset the flip-flop, we would make it 0, and we don't want to clear at the same time, so clear would not be activated. The other inputs don't matter when you activate preset, and preset is going to make the output Q go to 0. Okay, and therefore not Q will be, or excuse me, preset activated makes the Q output go to 1, and therefore not Q will be 0. Okay, So that's what the active low and active low preset, active low clear are all about. Clear makes the Q output go to 0 when activated, no matter what the other inputs are. Preset makes the Q output go to 1, no matter what the other inputs are when it's activated. And you never want to activate clear and preset at the same time, because that sets up an ambiguous output. And the reason we cover these two inputs at this point is because the next video we'll look at a counter that counts to some other number other than a whole number power of 2. Okay, so instead of a 4, 8, 16, 32 counter that we saw in the previous video, we'll see an example of a 10 counter. And in order to make a 10 counter, you needed to know about how a clear works.